Good afternoon. I will talk about how to turn R&D into solutions that you can build on. First, a few words about myself, only a few. My life for the most part is quite boring, but I want to pinpoint one specific thing here. I spent more than 10 years in and around IT organizations, and this has learned me a lot, and I will come back to that later in my presentation. Now, first things first, this conference is about omics data, with a focus on omics, and in my case on data as well, because I'm mostly focused on and interested in the data analysis part. Now, when we're talking about omics data, there's three main challenges that we have to deal with. First of all, there's the volume. Usually, whatever omics type of modality that we're talking about, it comes with a lot of volume. All right? Second is complexity, and I quite like this illustration in a paper by Kastowski and et al. Because it quite nicely illustrates the complexity of the types of data that we're working with. And then the third big factor is when we start to integrate different modalities. It's not only that we have to deal with the volume and the complexity n times for every modality, it's also that we want and need to integrate these different modalities, so the complexity still rises considerably. So these three main challenges are something that we have to keep in mind. Now, typically, what happens in bioinformatics when we want to effectively analyze this type of data, it's not just one tool that you should run in order to do the analysis part. It's usually a combination of tools. This is a conceptual overview of a workflow that we have built, and I will come back to the workflow. It's open pipelines. It's a conceptual overview. Why? Because every step in this workflow is rather a group of steps. It's not just one individual step. So as I pointed out already, this is part of Open Pipeline. You can refer to the QR code if you're interested. And just to zoom into the last part of this conceptual overview, you will see that already more than 10 steps are involved in this one specific part of their workflow. So imagine, well, in total there's more than 150 components that you can potentially run in the scope of this Open Pipelines workflow. Now, typically, there's a couple of people that are involved in analyzing this type of data. You see a few on the slides. And I think it's fair to say that if you take a look at what type of work they do, how they handle these tasks, it's not always in a very structured and very robust way. I think it's fair to say that these people are typically more on the research side of things, rather than on making things operational and robust. And this typically reminds me of when I was in IT. Remember my earlier career? The business requirements, questions from customers, things got more and more complex over time, and it just wasn't possible anymore to cope with this load, with this workload and complexity, just by doing things manually, ad hoc, with a bunch of people. And so what was needed at that time was more standardization, modularity, in order to cut the complexity. So in the end, what you want to turn up to is this kind of situation, let's say, with big thanks to ChatGPT. Now, if you dive into the matter and we take a further look at what kind of challenges that we're encountering, what kind of topics are relevant in this scope, in this context, there's a couple that I put on the slide. We're not going to tackle them all, we're just going to zoom into 4 of those, the green ones. And let's start with R&D versus operations. I only quickly touched upon that, but let me start with an anecdote here. 2 years ago, we were asked to implement a SCGPT tool. It was a tool that was just published, so a GPT approach to annotating genes in single-cell data. Okay, interesting. And we were told that the researcher who came up with the method already developed it completely and it was ready to go. And we just had to implement it in a workflow, the Open Pipelines workflow. We started working with the researcher, turned out, okay, she created the process in a computational notebook. Now, for those who do not know, a computational notebook is a very powerful tool for a researcher to dive into an analysis, connect to the data, see what are the results, create a plot, a table, whatever. A very powerful tool. It's just not something that you can take and just put in a workflow and think it will run forever in a robust way. It's not meant for that. It's meant for interactive work. So what we had to do was take a look at that code, work with the researcher, turn it into a module, and add that module to our workflow. Now, it's only possible to do that, that kind of transformation, to do it quickly, if you have the proper toolset and the proper platform to do that. In the end, we were able to, quite quickly, create a module, SCGPT annotation, out of this, which is now, since then, included in our Open Pipelines workflow. So again, there is a big gap between the researcher who has to innovate, who has to work quickly to come up with new scenarios, new prototypes, new ways of working on the left-hand side. But on the other hand, we often also need robust operations. We want to be able to depend on whatever has been developed on the left-hand side. And there's a gap in between, and somehow, if you don't think this through, and if you don't have the tool set and the processes, it's really hard to bridge that gap. To put it differently, if you want to run the scale that we did for Tabula Sapiens version 2, for instance, and this is just a subset of that data set, just to be clear, you don't do this from a notebook. You have to have different tools to run these types of data sets through your analyses. Second topic, reuse. All right, let's start with the story on the left-hand side. There's 3 conceptual workflows here. The left one is basically a pointer to Open Pipelines again. When we started developing Open Pipelines, quickly after we also started developing a high-throughput workflow. And I'll come back to the high-throughput workflow later, but just for now, know that this is the second workflow that we started working on quickly after the first one. And we developed the modules for Open Pipelines and also for the high-throughput pipeline, and we quickly noticed that some of those modules are actually shared. It's the same module with some different parameterization, some under-the-hood changes, but basically the same module. At that time, we didn't have the toolset yet to be able to share modules across workflows, so we had to copy-paste the module to the other workflow. But of course, there's 2 versions of the same thing that you have to maintain, which makes life harder. Later, this year, we started creating a spatial single-cell workflow. And it quickly turned out that lots of the downstream components and modules were actually the same or could be reused from the Open Pipelines workflow. If we didn't have the toolset then, we would have to copy-paste all these modules to our new workflow, which of course is a big pain to maintain. Now luckily, by then, we had our platform, we had our toolset, so what we are currently doing is basically we have this common set of modules that are used in various places, and we just create a dependency to this toolbox. And in terms of the spatial workflow, we don't copy-paste any modules whatsoever. We just point to as a dependency, we point to whatever is existing already in Open Pipelines, which is of course a way better approach to deal with these things. In other words, be careful. If you're doing R&D, just make sure that you can reuse it, that you can effectively use it, that it doesn't go to waste. Third topic, reproducibility. This is a nice one. It's all about containers, right? I was talking to a bioinformatician some time ago, and I asked him, well, what are you doing in terms of reproducibility? And he told me, okay, well, we have the code of our notebooks, we have it in source control, so that's fine. But basically, well, we should really create containers for all of our work. I said, okay, that's a good start. It's a necessary condition. It's not a sufficient condition. It only starts with creating containers. Let me illustrate that. Let's say, following scenario. You created version 1 of a workflow. It contains 4 modules, 4 steps. Simple workflow because it's all sequential. Every step has its own container. Now be careful, you have to version the containers. And if your container is gone, you cannot reproduce the workflow anymore. So it's important to keep versioned containers as well. But then you want to create version 2. Why? Well, two reasons. First of all, people recognize that with certain data sets, module B, there's a bug in it. So it doesn't work in some cases. So there needs to be a bug fix. Okay, fair enough. And also, we would like some module E at the end because perhaps there's some nice reporting that we would add to this workflow. Okay, nice, interesting. Now, turns out that module B, the output, the bug-fixed module B, the output of it is not compatible with module C anymore. Now you might say, well, okay, this seems a bit far-fetched. Well, I can assure you I've encountered these situations a few times the last years. So it's not so far-fetched as you might think. And so now the question is what to do now. Well, the answer is, let's take a step back and see how these kinds of things have been tackled in different IT organizations, but also in computer science in general, and just look at this with a different perspective. And then one thing you should notice is that B, the new version of type B, adding that bug fix is a completely different thing than adding a module at the end of your pipeline. This is new functionality. You add something to the workflow. The other one is a bug fix. So let's handle it as a bug fix, and let's call that version 1.1, because it doesn't add any functionality. But then how do I cope with the incompatibility of B prime? Well, let's add a module that only transforms the out of B prime to whatever C uses or needs as input. The end result will be the same, and your bug has been resolved in version 1.1, and you can safely create version 2 with new functionality and with a different type of B prime or the same one, it doesn't really matter. Both will have to be validated, but this is an easy job, and this will have to be validated from scratch. So please keep in mind that the shelf life of your analysis is only as long as you can reproduce it. Fourth topic, ease of use. Also a very nice one. I told you already that we have been working on this high throughput pipeline for J&J. It's been running for 5 years now, and recently we got a question of, can you maybe provide a different interface to their workflow? Okay, what should be changed? Well, we would like to have multiple inputs at the same time, so it runs the workflow in parallel. Okay, nice thing. But also we would like to provide the input via a CSV file rather than a form, basically, because this was the way that it was before. Okay, interesting. And then can we then maybe replace the form with that new format? No, of course not. We should still be able to use the old way. Okay, all right. If you think about this kind of requirements, it sounds really easy, but in practice it's not. Because when you look at, for instance, typical NF-core Nextflow pipelines, you get this monolithic structure, monolithic pipeline. It's not really modular, also, even though they call it modular. And you have this whole long list of possible parameters, and that's it. That's the interface. If you want to change that, you create a different version. But a different version, again, means additional maintenance, because you want to keep things in sync. That's not the way to do it. Okay, but then what is? Well, again, it comes down to creating the toolset, the ways to do that. What if we could just add a wrapper around an existing workflow that deals with these changes in requirements for input and output, for instance? So your inner workflow remains exactly the same. It is validated and it can be stable. It can be run as is, as it was in the past. But you add a wrapper around it that can deal with different requirements. Different requirements in terms of input, output, but maybe also you want to integrate with your LIMS system, or you want to integrate with the data governance policies that are available in your company. Alternative outputs, obviously, etc. Maybe you want to deal with some sane defaults for your organization. Again, without having to recreate or fork your existing workflow. And if you think this through, you can add as many of these possible alternatives as you want, because you only have to validate this workflow once, the rest is just a different interface. And that made me thinking that if you think about usability, usually we try to come up with the best design for everyone. But maybe it's the other way around. Maybe we just should think about how to make our systems as adaptable as possible. Okay, so this covered the 4 topics that I wanted to cover. You can find us at our booth. And if you're interested, please, you can use the QR code here for some more information about Data Intuitive and what we do. Thank you.